resources and ports. In this nugget, we'll be discussing resources and ports. We'll start off by talking about resources. Now, this is not resources like how much memory you have left or how powerful your processor is. This is resources that the devices in your computer will need to use in order to be able to interoperate with the system. This relates to interrupt requests and DMA and so forth. We'll also talk about serial ports, which is kind of an increasingly antiquated way to be able to transfer data, but will still appear on many computers, and so you'll still need to know something about those, as well as parallel ports, which are also becoming obsolete. But then we'll take a look at infrared as well. This is a wireless way to be able to transmit data or send and receive signals, and this is also becoming increasingly, not rare, but less and less popular in favor of other technologies such as Bluetooth. But you will still see it on devices and laptops and such. Then we take a look at IEEE 1394. Now we start to get into the modern age where we work with FireWire, or sometimes it's also called iLink. And this is a way of using a cable to connect devices to your computer for high-speed throughput, and also USB, which is another high-speed throughput method, and that's probably the most popular method. Have you ever tried to accomplish a task and then just realized you just didn't have the resources? It could be financial. Maybe you're trying to save up for something, and it seems to be taking forever. Maybe it's physical, and you just don't seem to be physically capable of doing something. I know yesterday my son and son-in-law decided they wanted to hike Camelback Mountain here in Phoenix, Arizona, and this is the most brutal hike in the city limits. It's very, very strenuous hike and difficult. In fact, every year there's several people that have to get helicopter rescues off of this mountain. Well, my son and son-in-law finally talked me into going, and they were able to handle it with plenty of energy. They had plenty of resources. Here's my son after he got to the top. Here's my son-in-law. He's like a fitness model and an actor and everything, and he's doing push-ups once we get up to the top. So I'm just like dying and huffing and puffing and out of breath. I just didn't really have the resources to accomplish that task, at least with any sense of pride by the time I got to the top. Well, it's kind of like that with your computer as well. It needs certain resources to be able to accomplish certain tasks. Otherwise, it would not be capable of completing some of these tasks. Now, besides the physical hardware resources that almost go without saying, there's also certain other resources that need to be in place in order for the hardware to be able to interoperate with the rest of the system and with the operating system, whatever that might be. So these resources would be things such as the direct memory access, or DMA. Not all devices require DMA, but certain devices are able to use it. And what this means is that it will not have to send whatever its information or request is through the processor. Most everything else in a computer has to go through the processor. It's kind of the traffic cop of the whole computer that determines and calculates all of the functions that have to take place. Well, if it's something that can get from point A to point B and not necessarily have to require any processing on its own, it's just kind of a raw data, for example, it can use direct memory access, or DMA. Also, you have to have an I/O address for certain things as well. This is simply kind of an identifier. For example, if you were a ship captain and you were going into a port, the port master or whoever they are that work in the port, they would tell you probably by radio that you need to go to port 27 or something like this. That would be where you go into and out of the port. That would be your I/O. Same thing is true of information that passes to and from a device in your computer to the rest of the system. It has to have kind of a designated space where it goes in and out of that information. And then you'll also have interrupt requests. These are something that requests attention from the CPU. It's just like this. I was at Starbucks early this morning drinking my quad venti extra caramel macchiato, and you know where a lot of my budget goes, don't you? And there was a child in there saying, "Mommy, mommy." He kept trying to get mommy's attention. I don't know if the child wanted a cupcake or something like that, or maybe the child also wanted a big shot of coffee, which I don't think he needed. Anyway, he kept saying, "Mommy, mommy," trying to get the attention from the mom. Well, that was definitely an interrupt request. It was definitely an interruption to my peace and quiet as well, because this went on for quite some time. But anyway, it requests attention in your computer from the CPU. You see, the CPU does not know that it needs to give a specific device any attention or processing cycles until it's notified by that device, and devices use interrupt requests to talk to that CPU, or at least to request that attention. And then there's also a memory address. Now, memory addresses, and this is normally going to be, by the way, I don't have it on there, but between 640K and 1 megabyte. This is normally a space that certain devices will need to reserve in memory. It needs to reserve a portion of that to store information. For example, if you have a RAID card or some kind of a device like that that has its own BIOS, then very often those devices will load their BIOS data into the memory somewhere in this space. And that way it can continue on through the boot process while Windows loads and continue to use whatever data it loaded into there about its configuration. Also, other devices that might need something like this would be something that has memory. So, for example, a video card. Very often, actually almost always now, has memory, 256K, 512 megabytes, a megabyte, or more sometimes. So they will also have to have some space carved out of this space in memory to use as a memory address to load and store information about themselves. Now then, here's a document that I've made available for you up on nuggetlab.com. It's called portresources.pdf. And we identify some of those resources here, not all of them, because some of them can be randomly assigned, so you never know where exactly a specific device is going to require something in its memory address, for example. But for things like interrupt request resources and DMA channels, there's certain kinds of default configurations there that you do need to be aware of for A+ exam purposes. Now, I didn't see it anywhere on the A+ exam objectives that you need to know these resources for interrupt request or DMA or any of these other things, but just trust me on this. From experience, I think it would be a good idea to be well aware of some of the most common settings here, especially for interrupt requests. And that, again, is what IRQ is interrupt request. Now, so what you'll have here is, for example, 0 is the system timer, 1 is the keyboard controller, and these are things that are kind of hard-coded to always use these interrupt requests. Some of them you could change. However, if you do that, you risk locking up your system or blue screening it or something like that. So most of these default items you should really not mess with unless it's causing a conflict with another device that also requires that same resource. And then you're just going to have to take the risk and try to change the resource. Now, I also want to point out that in current computers, and I mean anything made within the past 5 years or so, you're not going to really have much issue with interrupt requests. I remember in the earlier days of PC computing, we used to have only the first 8 interrupt requests. On older computers, you didn't have these down here at the bottom. And these were difficult because they didn't really quite mark those out there, but more like that, I guess. This was difficult because a lot of times you'd have more devices that needed interrupt requests than you had of available interrupt requests. And so, for example, if COM2 or serial port 2 was requesting or using interrupt request 3, then what you would have to do is just commit to never ever using COM2 so that you could put in that other expansion card or other device that also wanted to use interrupt request 3. And if you ever tried to use both of them at the same time, number one, let's say it was an older kind of a mouse that you plugged into a mouse port, and it also needed that COM port. Then what would happen is one or the other would either fail entirely or work intermittently. So if you had both your mouse and COM2 that were trying to use the same interrupt request, then your mouse might get kind of herky-jerky and you might move it and nothing would happen for a few moments, and then it would suddenly slide across the screen, something like that. Or one device stops working or both devices stop working. Now then, if you want to see some of these resources that your computer is using, there's 2 ways to go about that. Number one, you can go through the BIOS, which we've already looked at in a previous nugget, and you can see some of the hard-coded designations for resources such as your interrupt requests. The other thing you can do is to go into Device Manager, and you can look at these 16 different assignments. Let me go back to this. See, these are 16. Even though it ends at 15, it starts at 0 using ordinal numbering, so that's a total of 16. And what we have with that then is the ability to see all of those assignments, if any are used. So what you would do in order to obtain that information is to right-click the computer and then choose Manage. Once you've done that, and I've already done it here, then you will have Computer Management open. Then you can go to the Device Manager. Now, this doesn't actually show it by resource right now. It just shows all of the various devices that I have inserted into this computer. But, for example, if I were to go to COM1 and double-click on it, or right-click on it and choose Properties, they both do the same thing, then I could go to the Resources tab, and it would show me that it's using interrupt request 4. Now, in Windows, you can sometimes change some of these settings, although it's becoming less and less available than it used to be. It used to be that you could do this a lot in Windows 95, for example, and 98, and somewhat in XP. In most current operating systems with current hardware, this is no longer really something you can change, and that's fine. It used to be that when we realized that we couldn't change these things anymore, it seemed very inflexible, and some people were upset. But a big reason why these are not changeable anymore is because, number one, it is a way of shooting yourself in the foot, and sometimes you can make a change here that makes it difficult, if not impossible, to use your computer or even boot the operating system. And the other reason is because we now have something called ACPI, or Advanced Configuration Power Interface, and this is not really just relating to power management. This actually goes a lot farther beyond that, and let me show you that by way of illustration here. If I change this view to resources by type. Now, when I've done that, notice that we now see all of these different kinds of resources available, and if I go to interrupt request, look, we have our standard 16, 0, 1, 3, 4, 6, 8, whoa, 100. Where in the world did that come from? I thought you said there were only 15 of these, James. Well, that's true, but because of the Advanced Configuration Power Interface, and you can see the designation there, it's able to give you a bunch of interrupt requests, whereas in the past we had significant difficulty using all of our resources without coming into conflicts. For interrupt request conflicts, now with ACPI, which is just a newer technology that's available in every motherboard nowadays, then it can go out to who knows how many interrupt requests. Here we got up to 190 interrupt requests that could be used. So we really just do not even have resource problems with that anymore. And if you ever run into a situation where it presents to you that you're having a conflict with interrupt requests, that must certainly be on the most archaic of computers. And then returning here, you can see that some of those things were mirrored exactly the way we have them in the list. For example, I don't know if you noticed it, but the system timer was on interrupt request 0. We had these COM ports assigned just like the way you see them here on 3 and 4, and so forth. Now, I also have here the DMA channels, the most commonly used DMA channels. Some sound cards, especially older ones, would use DMA 0. Okay, so that could be some sound cards that use that. Or the most common sound card out there has probably been Sound Blaster for many, many years right now. Sound Blaster is made by Creative Labs, and you can see the products at creativelabs.com. And no, I don't get a kickback for recommending their website. I'm just pointing out that they're probably still the most commonly used ones, although there's other good brands out there as well. Now, the Sound Blaster cards kind of standardized on using DMA1. I cannot seem to just select one thing here. There we go. DMA1. And then there were also other generic sound card manufacturers out there, or cloned sound card manufacturers, that would also use that same item. In fact, they would be usually identified on the box. It would say that they were Sound Blaster compatible, meaning that they met all the same standards and basic implementations for handling sound that the Sound Blaster card series does. Then you can see some others for floppy drive and LPT port, for example. And then there's even another space for another sound card if you want to have one down here. And then finally, 6 and 7 are pretty much the only two left that you can assign for user hardware if any of these others are already occupied, or if all of the others are already occupied. But once again, because of current technologies and current systems the way they are nowadays, rarely, if ever, do we have DMA channel kinds of conflicts or problems. And then finally, down here at the bottom, this is something that I would say would be important to know and understand, and that is the serial and parallel port resources. These are just common kinds of things that have been kind of the staple of any A+ technician's diet, that you do definitely need to know these things. Some of this is repeat. For example, COM1 is on interrupt request 4, COM2 is on interrupt request 3, and so forth. And then these serial and parallel ports are all designated as follows: COM1, 2, 3, and 4. Notice that COM3 and COM1 share an interrupt request. So if you're working with older hardware that you have to use serial ports for, and by the way, serial ports and COM followed by the numbers, the same thing. So this would be serial port 1 or COM1. Anyway, if you working with an older system where you had two devices plugged into serial ports, you better make sure that one is assigned on COM1 and COM2, but not COM1 and COM3 at the same time. Why? Because look, they use the same interrupt request. Okay, so if I had two modems, for example, and one was on COM 1, the other one was on COM 4, and I'm trying to use them both at once, I'm going to have a problem. The place where that's not so much of a problem, and by the way, the same is true of COM 2 and COM 4. You can't use them both at the same time because they're on interrupt request 3. But where that's not so much of a problem is with LPT ports. For LPT 1, it uses interrupt request 7, but it's much more forgiving in terms of sharing. So sometimes you could put a sound card, for example, if there were no other interrupt requests available, you could assign interrupt request 7 to the sound card, and it would usually play nicely with LPT 1. So anyway, do you have to memorize every little thing about this? You know, like these I/O addresses, which would be difficult to memorize because of just the way they look and everything. No, again, I don't think you have to memorize these, but I would be very familiar with them. Know that COM 1 and 3 use the same interrupt request, COM 2 and COM 4, and that's not too hard to memorize these numbers here. And the I/O addresses, I would just be familiar, you know, on site with these so that you could know that if it says that COM 4, for example, uses 03F8 through 03FF, and these are hex numbers, by the way, designating memory addresses, then you would say, that doesn't sound right, because this is what it's supposed to be using, okay? So just in your mind, you can say, you know, something kind of looks out of place if they try to tell you that this I/O address belongs to COM 4, just as an example. Now, since we already referenced COM 1 through 4, let's go ahead and address these things. These are actually, again, known as serial ports, and that's because of the way that the serial communication takes place. So the source of the communication might be, who knows what, a modem or some kind of a data transfer or whatever, and it just goes serially. In other words, like in a single file line. And this bit of data does not get transmitted until this bit of data has already been sent and has been received on the other end. So it's all data that goes in a single file line, so to speak. And these are referenced by logical ports designated COM 1 through COM 4, as we already saw in the previous PDF. Now, what's the kind of connector that these things use? These will use ports DB9, or rather connectors called DB9 and DB25. DB9 being the most common, indicating that there are 9 pins, and then it's a D shell connector. In other words, it's shaped kind of like a D, where it's wider at one side than it is at the other. We'll see a picture of it here in a moment. And then this one's a 25-pin connector, which isn't used as often. In fact, very often, only 9 of these pins are used anyway, so a lot of people said, hey, why are we even using these bigger, more expensive connectors? Why don't we just whittle this down and use only 9, because that's normally all we ever care about anyhow. Also, by the way, depending upon the manufacturer, there is such a thing as a standard serial cable where the pinouts are industry standard, but very often you'll find specially made serial cables that are made specifically for different devices, where maybe some of the unused ports, for example, on the DB25 are designated for a special purpose from a manufacturer, or maybe there's a couple of pins in this one that are crossed over for different reasons and the like. Now, I'm not going to spend a whole lot more time on serial ports, only because they've largely been replaced by other things, such as, you know, even wireless technology, such as Bluetooth, or faster connections such as USB or FireWire. But one of the advantages we still do have with serial ports is that it can have a maximum cable length of 50 feet. That's actually pretty long for a cabled device. Also, what would you use this for? Well, you could use it for a PDA. In fact, the first PDA I bought for my wife was one that connected by serial port to her PC, and it was used to sync up all of the data. This is pretty antiquated now. Nobody has PDAs anymore. We all have iPhones and Droids and all those sorts of things, which kind of integrate all the functions of a personal digital assistant with our phones. And normally they'll connect by USB connections. Also, printers would connect using a serial port. Sometimes you'll still see this, especially with terminals. This could be something like a cash register type of a terminal. Maybe it's something at a shop where you go. Maybe you go to an auto body parts supplier or something like that, and you buy a headlight. Well, they may print out using their cash register kind of terminal thing there to a printer connected by a serial port. And then also a lot of older printers will still use serial ports as well. Particularly in both of these cases, that's normally going to be a dot matrix impact printer, and we'll talk more about printers in a future nugget. And then also you can use these for modems. A lot of times the modems, especially the external ones, would use DB25 on the modem side, so it used the larger connector on the modem side, but on the PC side, the other end of the cable, would be a DB9 on the PC side. Okay, so one end of the cable would be DB25 shaped, with 25 pins in it, most of which are not used. And then the PC side would be a DB9. Also, it could be used for a null modem transfer, and we still could sometimes use this. But what this does, it really doesn't have anything to do with using a modem, even though the name is in there. What this does is it just transfers data from one computer or device to another. And here, if we take a look at the back of this PC here, I'm just going to kind of zoom in here so we can get a better look at these serial ports. Now, looking at these, what we have here is pins 1, 2, 3, 4, 5, and so forth until we get to pin 9. This is pin 1. Notice that the D shell shape, remember it's a DB9, the D being a D shell. It's a little wider up at the top. And if you kind of turn your head to the side and use your imagination, it looks a little bit like a D. That's pin 1. That's pin 2 right there. That's pin 3 right there. Oh, pin 2 is normally used to receive data. Pin 3 is normally used to transmit data. And in terms of the null modem idea, what we would have here is we would send this through to another serial port, and I'm not even going to attempt to make a D shape down here, but this would be another serial port on maybe a laptop. Maybe I've hooked my laptop up to this PC because I want to diagnose some issues that take place during the boot process. Well, with a null modem cable, I could send out of the transmit on this computer, but when it reaches pin 3 on the opposite end, that's also transmit down here. That would be a conflict. We would have two pins that were set to transmit, and I would never be able to receive the data. So what happens here is, then in the cable itself, it crosses over, okay, to pin 2 instead. Okay, pin 2 here, pin 3 here. And then on the receiving end, it would cross over, and it would connect to pin 3. So there's a crossover that takes place directly inside that cable, allowing a null modem transfer to happen. And then a modest improvement over serial ports would be the parallel port. The parallel port runs 8-bit parallel. That means that as a serial port, it would have a single file line of data. Well, with a parallel port, you can go 1, 2, 3, 4, 5, 6, 7, 8, all sending data at the same time. Got a little off track there, but anyway, you get the idea. Okay, so they can all send data at the same time. The thing is, with parallel data like this, all the bits of data have to cross the finish line, so to speak, at the same time. This makes it a little bit more difficult to synchronize and a little bit more difficult to engineer, especially over longer distances. That's why serial ports could go up to 50 feet, whereas parallel ports, as you can see here, are much shorter. But anyway, parallel ports have these designations, or otherwise known as logical ports, in other words, what they're called in the system, LPT1 and LPT2. You can use cable lengths commonly found in 6 feet, 10 feet, or 15 feet, although Hewlett-Packard generally recommends 10 feet, and they're the ones that make the most printers, and in the old days, parallel interfaced printers. They use a DB25 connector, a D-shell connector, and of course it has 25 pins on it. And then strangely, on the other end of it is an entirely different kind of connector known as a Centronics connector. We'll take a look at some pictures of those here. Actually, let me just show you those now so you get a frame of reference. So then here's an example of the DB25 parallel port connector, and if you want to take the time to count all these little pins, you'll see that there's 25 of those. This one's known as the plug side of this, and this would be pin 1 on these kinds of cables, okay, just if you ever need to know where pin 1 is. And then the Centronics end of that would be like this. This is what it looks like. It's just a totally different kind of a connector, and it attaches through pressure. There's kind of a springy little connectors or contacts in here, and they connect with the normally this will plug into the printer if you're using a printer, and then there will be some metal, I don't know what you really call them, but they're metal devices that you swing up, little wires that you swing up into these things, and it kind of locks into position and helps to secure this cable into the printer. And then how do we use those parallel ports? Well, number one, we could use them for data. Again, it's a way of transmitting data, same way that we could with serial, although parallel will be much faster. In the old days, we used to have a product called Lap Link that you could use to transmit data from a hard drive to an external media source, such as a zip drive, for example. And that might be useful if you had some kind of a cloning software, for example, and you wanted to clone one computer onto another. And we'll talk possibly more about that at a future point in time. But the basic idea of that, as long as I brought it up, is uses software to make an exact mapped image of the hard drive on a source computer, and it can place all of that data exactly the way it was on a destination computer, and then you can boot it up and run the operating system from that destination. Now, there's certain limitations with that. If the hardware is not an exact match, especially in the old days, that could really be a problem. But at least it was possible, and you had something like LapLink to make that sort of thing available, or to just transmit data off of the computer if you didn't have, like normal network connectivity where you could do a file transfer. And then the more common use will be for printers, and this is by far and large, the biggest part of using parallel ports. There's a few different kinds of parallel ports. One of those would be a standard parallel port. This is generally considered unidirectional, even though it's got technical capabilities that allow it to both send and receive data. It can only do one or the other at a time. It cannot do sending and receiving simultaneously. And then a modest improvement over SPP would be in the enhanced parallel port. And what this does is it just provides a faster speed than we could have with a standard parallel port. However, by far in the latter life of parallel ports, the enhanced capabilities port was normally the better of all of these. This would allow something called daisy chaining as well. So for example, you could have the port plugged into the back of the computer here, like that's my computer, and then I might have a printer here, and then on the back of this printer there might be another parallel port that could connect or daisy chain yet another device or another printer. Didn't really see that happen very often, but at least the capability was there. And also with this, you're going to be better off if you use an IEEE 1284 cable, and it'll say that right on the cable. Generally speaking, what this will allow is, number one, it's shielded better, so you get more reliable data transfer. It also will transfer data faster, and it will give you bidirectional support, which you would have with ECP. That way, for example, if the printer runs out of paper, it can send a signal back through the printer cable to the PC and interface with or interact with some kind of software or the operating system, and a message might pop up saying you're out of toner, you're out of paper, or whatever. And also, I don't think I've mentioned what IEEE stands for, by the way. That's the Institute of Electrical and Electronics Engineers. And these are the propeller heads that come up with all of these kinds of standards and the electrical design for a lot of the things that we work with in the PC world, as well as many other kinds of technologies. Of course, here returning to the motherboard, we see that this is a parallel port, this pink item right here, and it's got 25 pins that would receive the 25 pins in the parallel port cable. And then as far as the parallel port and the serial ports, or the gaming port for that matter, just about any of these, if they don't already appear on your motherboard, largely because they're kind of becoming, obsolete, then you still, if you need one, you can still get one. You can get them as adapter cards. I think I got a picture here. There we go. You can get these as adapter cards right here. And this was a PCI Express one that you just plug in, and then it has a serial port there. And then this will actually give you two serial ports. So you have one on the card, and then another one that plugs into a header on the card, and this would then take another slot. I don't know why they just couldn't put two serial ports on the same space here. That way you don't have to use another slot on the case, but that's the way they did it. Another thing to keep in mind, though, is sometimes you can also get these ports, again, serial, parallel, game, whatever, and you can just put those in one of the blanks in the case, and then this cable back here would plug into a header, not necessarily even on an adapter card like this, but it may also plug into a serial port, parallel port, or gaming header that appears on the motherboard. Now then, another way to make connections to your PC is to use infrared, which doesn't require any cables at all. It's all transmitted using infrared light signals, basically. And this is something that comes about from the Infrared Data Association, and I only put the acronym up there because you may have seen that from place to place and wondered what it stood for. They're the ones that come up with the standards for the whole infrared spectrum of how the technology is used. One of the key weaknesses of infrared, though, is that it requires a line of sight. You'll see this very often. For example, even at home, when I was watching the Olympics earlier today, I tried to use the remote control to turn on the television, and somebody walked in front of me, and I was incensed that they blocked the signal that prevented the television, my beloved 52-inch Samsung flat-screen television, from turning on and showing me the spectacular glory of the Olympics. Anyway, it does require a line of sight. Also, it does require some physical resources as well, in that it will occupy either a COM or an LPT port. And it's going to need to use the resources from one of those ports to actually send and receive the data physically into and out of the computer. Some of the uses we have for infrared are also PDAs. Remember I said earlier you could make a serial connection, which is really antiquated. Well, infrared is nearly as antiquated as well. We hardly ever use this anymore, but it still might appear on certain PDAs. And you can use that to, of course, transfer data or to synchronize your PDA to whatever, Outlook or your email program or something like that. And then you can also use it for just normal data transfer. I remember years ago, this is probably in the late 90s, I was at a conference and a friend of mine was also there, and we realized we needed to exchange some files. This was before thumb drives even became prevalent, so this is how far back I go, folks. Anyway, the only means we could think of at the time was to use infrared. So we set up a partnership between our two laptops, and he transferred some files to me so that I could work with them, and we just did that using infrared. So that certainly is another way of doing this. There are some printers that are capable of using infrared as well, and this is just something that is known out there, and it's documented that there are printers like this. The truth is, I've never even used one, so I don't know why I would really want to, because the line of sight issue, if anything ever blocks the signal between the infrared transmitter and the printer as the receiver, well, you could end up with a print job problem. So anyway, I've never seen one or worked with one, but they're out there apparently. And then, of course, you can also use a keyboard and mouse in infrared. This has been largely replaced with Bluetooth, which we'll talk about at another time. Oh, I guess I got it down there at the bottom. Anyway, it's been largely replaced by Bluetooth. I used to work with a guy that was a big financial planner here in the city of Phoenix. And he would bring people into his conference room, and he wanted me to set up his keyboard and mouse on the conference table wirelessly, because back then that was a big deal when, you know, you got no cables connecting all of this stuff to a PS2 port or something. So he would show all of this stuff off, but we really had problems because he liked to face towards the window, and the screen that he wanted to show everything on was behind him, and the computer was in another corner of the room. Anyway, we had very difficult time getting a line of sight, and he would have to tilt things just so in order to get that infrared keyboard and mouse to work at all. And it was very frustrating. Well, nowadays, if I worked for that same person, we would have a much better success because we could use a radio-based keyboard and mouse, and there's some that will have a short-range radio capability. And there's also Bluetooth, which is probably more prevalent and probably a better solution. And again, we'll talk more about Bluetooth at a later point in time, probably specifically when we discuss more about networking. And then you may have also heard of something called IEEE 1394. This is more colloquially referred to as either FireWire or iLink, but it's all really IEEE 1394. iLink is the Sony designation for that. This allows you to connect up to 63 devices, maybe in a daisy chain, or you can use hubs in order to be able to do this. And it provides for hot swapping, which means that you do not have to shut down the computer or the device itself to be able to just plug it in, to use it, or unplug it to remove it, and it doesn't hurt anything. Whereas with early versions of PCs, just the very thought of doing that kind of thing was kind of prohibitive, and people were concerned that it would lock up the computer, and very often it would, or cause other catastrophic problems or data loss or something. Also, this is something that's known as isochronous. Well, what is that strange word, isochronous? That means that the data is going to be sent in a continuous stream and without interruption. That contrasts a little bit with USB, which is a very good technology, but which could potentially pause at times for check data, whereas this will not. And that's one reason why you can see down here at the bottom, it's great for something like digital video. You'll find that your digital video data stream will normally transmit from the camera to your computer, for example, more reliably if you use a FireWire connection than if you use a USB connection. And that's just, part of that's just experience on my own part. But even though cameras will very often have both of those kinds of connectors to them, I think that you'll find that you'll get a better result out of IEEE 1394 or FireWire. By the way, that's the Apple name, and then the Sony name is iLink. And then the speeds for this. How fast can it go? Well, the original standard was IEEE 1394A. This allowed us 400 megabits per second. 1394B, which is the more current standard, allows for up to 3.2 gigabits per second, or 3200 megabits per second. Again, this is very good for digital video, and it's also very suitable for external drives or readers of various types. And then as far as the ports themselves are concerned, you can see here's an example of a FireWire port that we have right here. And this particular one is shaped uniquely so that you cannot plug in the cable into this upside down or backwards or anything like that. Notice that it's flat on this end and it kind of comes to a rounded edge on this one. And that's the orientation of that particular type of cable. That would fit perfectly into that slot. And then notice here we've got, this one's going to just go into a blank place on the case, and then this is our header connector right here. Notice that it's got an empty spot right there. That's for keying purposes, so that when you connect it to the motherboard, you can correspond the empty space on the block there with an empty space on this header, and then therefore properly orient that item. Now, one thing to keep in mind is that if you have to reach inside of a case to put that in, make sure that you know exactly where you're putting this, because you could potentially shift this accidentally to the right, and then the empty block would be over here, and then one of the pin locations would be over here, but you would leave these two pins uncovered by the block, and everything would be shifted to the right a little bit. Well, that causes a problem because some of these pins are for transmitting and receiving data, and some of them are for power and ground. And if you shift this over to the right accidentally and leave part of the block dangling off the side and leave these exposed, then what will happen is you're going to be shooting power into a location on that block that was never designed for power. So you could totally short out or ruin your entire 1394 capability on the motherboard. Don't ask me how I know about that, by the way. Now then, here's just another example of some of the connections we could make. This is the back of an external hard drive that I've used many times in the past. And here we see a USB connection, which we'll talk about shortly. But we also have a couple of different kinds up here. This is an IEEE 1394, as you can see in the plastic there, that's stamped into the plastic. This is the 6-pin design. If I zoom in a little bit closer, I think I can hold resolution here. Then you can see that we can only see part of it, but there's 3 pins here, 1, 2, 3, and then on the other side of this, there's 3 on the underside of this as well. So there's our 6 pins for a total connection. This uses 4 pins for data and 2 for power. But although this is a self-powered device, that's where I would plug in the 110 power right into this. Actually, it goes through a little brick thing, you know, so it kind of reduces the power by the time it gets here. As you can see, it only needs 12 volts. And then we have here a 4-pin connector. This is what iLink uses. It's standardized on 4 pins. This is only going to have data connectors. So this is not going to support the 2 additional pins for power. So whatever device is going to be using a 4-pin connector like this is going to have its own power source. And then as far as how the cable looks, this would be a 1394A cable. It's supposed to be a 3 there. 1394A cable. That gives us kind of this D shape on the end of this, and there will be 6 contacts in there. This is for the original standard 1394A, and it gives you up to 400 megabits per second. But in this particular photograph, I've actually also got another end of the same cable. The other end of this cable is this. Okay, that looks quite a lot different, doesn't it? This is a 1394B cable. And what we see with this one is it's known as a bilingual cable. It uses 9 total connectors on the top. I don't know if you can see them, kind of small there. But there's 5 connectors on the top, and underneath that you would be able to see 4 additional ones. And it has kind of a narrow notch up here at the top. The narrow notch up at the top designates this as bilingual, which means that you can connect this to the device, whatever you're trying to work with, and the other end, for example, into your PC, and you can work with either a 1394B device, but connected to a 1394A port, and that should work just fine. And then another kind of cable you might see looks amazingly like this. It's almost identical to this 1394B look that we have, except that the notch, the key up here at the top, is actually a little bit wider, comes out a little bit wider, and that would be what we call a 1394B beta cable. And that means that it will only communicate with other 1394B devices or ports. Now, also by way of example, this is a photograph that I took of my actual 1394B cable that I'm using to connect to a device right now. You can see a little bit more clearly here the 5 pins there. And we also see this notching right here, this keying up here at the top. This would be identified as a bilingual cable because, in fact, indeed, again, the other end of this cable is a 1394A connector that plugs into the back of my computer. And then this is what it's actually plugged into right now. This is a SanDisk card reader for compact flash. By the way, there's the symbol for FireWire, just so you can easily identify that. And if I push in a little bit further here, you can see how that connector would actually fit in there, and then there's the actual 5 pins that we see there as well. But again, kind of the square-shaped looking thing there. And then this is the front of that same card reader, CF, compact flash. You can use a similar kind of thing. It could be USB, it could be FireWire, and it could be a single type of card reader, which is a compact flash reader that I'm looking at here, or it might be one of those multi-card readers, which addresses all different kinds of card formats. It might be a 7-in-1, for example, where you can insert a compact flash or SD or Memory Stick Pro, all different kinds of removable storage, actually flash memory into that reader, and then be able to use it within Windows Explorer. And then once I've plugged in a compact flash card into that, and in fact that's exactly what I've done here, then we can go into Windows here and we can see that it's now identified as a device with removable storage, and I'll just double click on that, and I can now see in this the actual files that were on that compact flash card, and I can treat these just as if they were any other kind of storage. I can drag and drop these, I can copy and paste, I can do whatever I need to. In fact, I want to show you this. This is a picture of my son. We just got back from Camelback Mountain, and here's us hiking up there after we'd gotten to the top, and you can see him. He's pointing to a spider that he saw. He's kind of deathly afraid of spiders, but you can see how high up there we are. There's little tiny houses here in the background. But anyway, I got this photograph off of that particular card reader through a FireWire cable. So hey, there you have it. Technology in action. Now let's take a look next at the probably most common type of a connection you'll be able to make for any kind of peripherals or external devices. And that would be the Universal Serial Bus. This has a couple of different standards. The first one is version 1.1, which is capable of a low speed, 1.5 megabits per second, but which is perfectly suitable for things like keyboard and mice and something that doesn't need a high data rate. There's also a 12 megabit per second that it was capable of as well, but it really didn't get to be quite as useful because this was still quite a lot slower than FireWire until we got to version 2.0, and then we were able to get 480 megabits per second. Then it started to compete a little bit better, and then I've used this many times for things like external storage devices, such as external hard drives and things, and that's a reasonable data rate that we can use to transfer data. Now you can daisy chain up to 127 different devices. You might have a computer here, and out of here you might have a single connection to some kind of a printer, the printer might have another USB port on it as well that you can daisy chain off of that, some other kind of a device. Or probably what you might more likely see is that you might also connect this to a monitor. Now, of course, your monitor will have a video cable connected to your computer, and it'll have a power connection to an outlet, in the wall and everything. But this might be your monitor here, and in a lot of monitors now there's also USB ports, so you might have 1 or 2 or 3 USB ports that you could then plug additional devices into as well. And then another thing you might see, and this is how we get our daisy chaining going on when we get to larger implementations, is you might have a USB hub. And this might have, 4, 6, 8 different connections on it, which you would then put other devices on the ends of that. And one of the devices that you might decide to put on there would be, guess what? Yeah, another hub, which you could then put additional things on. You can see how it kind of goes on and on and on. That's how you're able to get up to 127 devices. And you can use cable lengths of up to 16.4 feet. Although you might be able to kind of cheat that by, putting together hubs. So if you can't get if you can't bridge the distance between your computer and whatever device you're trying to communicate with, maybe a distant printer or something like that, you can put a hub in between your computer and that printer, and then extend the length of the connection. Although also, the hubs that you use, the better ones are going to be powered. You can use these, generally speaking, as powered or non-powered. If they're non-powered, then they depend upon power from the originating USB port back here, okay, if they're non-powered. So if this is a non-powered one, and then I've got another hub out here, and it has to supply power to devices, then you probably need to power this one in order to be able to supply power out here. Otherwise, you're really extending too far great of a distance the ability for that USB power to be able to extend out. Sometimes you can also, though, cheat this as well. I did this, in fact. I've got in my upstairs loft a video camera, just like a webcam camera, because when we first moved into this house, my kids were younger, and I wanted to know what all the racket was that was going on upstairs. So I had a camera put in there. Now we can see I've got it turned on right now, and you can see I've got a few different things going on up here. My wife's interior designer, so she's got some blueprints here apparently, and there's a weight bench. People wonder how I get my athletic physique, folks. I've never touched that weight bench in my life. I just watch sports. I don't actually do anything. So anyhow, I don't know why we even have that. It probably needs to be put in the next garage sale. And then if I'd hear a bunch of commotion up there, I'd look over here on this couch, and inevitably I would see my son jumping up and down on this couch, at least back when he was younger. These things are also, by the way, hot swappable, so you should be able to just plug and unplug them, just similar to what I showed you with IEEE 1394 earlier. In fact, let me go to that camera. I'm just going to go over here right now, and I'm going to just unplug this from my computer right now. Okay, and there it goes. No camera connected to the computer. The system did not lock up, and I didn't get a blue screen or some nefarious error or warning message or anything like that. That's just the way USB is designed so that I can unplug it. Do keep one thing in mind, by the way. This is true both, especially of USB and FireWire devices, but even more of USB. When it comes to the drivers for your devices. We'll talk more about this later in Windows discussions. But the driver is the interface that allows the operating system to communicate with the actual hardware. And when you plug in devices such as multifunction printers, always check to see whether or not the manufacturer recommends using the install disk first to install the software and or the drivers. Because otherwise, if you just plug in the device, plug and play should detect that device, but if it may not use the proper drivers or may substitute drivers that would be less suitable. So always read to find out, first of all, if you should install the drivers first. And most of the time, especially for multifunction devices, you should. USB is also broadly compatible. It works with Linux. It works with Macintosh systems. It works, of course, with all current versions of Windows. It works with our cell phones now. My cell phone is actually plugged into a USB port, and that's how it gets charged now. It just draws power through the USB port. So a high degree of compatibility with USB, and plug and play is a big part of that. Just as a quick side note, by the way, I've also got this in our PDF file, but there's these speeds that we have for version 1 and version 2 are certainly good, but there's a newer version. I'll just put this out to the side. Version, I don't know why I'm getting an hourglass here, version 3.0 that's capable of 4.8 gigabits. That'd be a lowercase b, per second. Okay, so that's pretty screaming fast. That's not part of the A+ exam objectives because it's brand new, but there is a new emerging standard like that. And on the motherboard that I'm recording with right now, I do have 2 of those version 3 ports available. And then, since I mentioned the speed of USB, I'm going to return briefly here to this bus bandwidth document. And just for your own study, I've made this available for you. Remember, we talked about earlier 1.5 megabits for the first version, of which could go up to 12. The current version of USB 2.0 goes up to 480 megabits per second. But the emerging standard of USB 3.0, known as super speed USB, will go up to 4.8 gigabits per second. So that's 4,800 megabits per second, or 600 megabytes per second. That's pretty screaming fast. And then we have all of our 1394 standards here as well, which I've already mentioned. And then here's just a graphic of some USB ports. There's 2 of them on here. And you can see that they're keyed so that you cannot plug things in, upside down, sideways, or backwards, or whatever. But this is one of the ports. This is another one. And there, of course, is a FireWire port over there. For the different types of USB connections that you have, you'll see a couple of different kinds of cables. Let's go ahead and take a look at one of those. This would be the A cable. This would be what would fit into, in fact, those ports that I just showed you in the previous picture. And you can see kind of how that would mate perfectly into that. And this is another kind of cable. This would be known as a USB-B type of a cable. Okay, so that's a B cable. And that would connect to devices such as, I think I had one here somewhere. There we go. This would connect to something like this. This is an external drive, and we kind of saw another picture of one of these earlier. You can see again how the shape of that would fit into that just perfectly. Most external drives, for example, or external card readers or USB hubs will use the B-style connector like we see here. This is another kind of a connector that's known as mini USB, and you can see it kind of has an odd shape or a unique distinctive shape to it as well. This is going to be more likely to be used for things such as USB-enabled phones or smaller devices like smaller drives. I have some Western Digital Passport drives that use this kind of a connection. It's mostly just for sake of space-saving design and compactness. And then here's simply a list of the different types of connectors that you might see. The type A we already looked at, the type B we also already looked at, and then we also looked at the mini B that we have right here. There is also, just FYI, a micro B. This is something, again, that's even smaller than the mini B in many cases, at least it's slightly narrower. And what this does is allows us to connect to, again, other types of devices. For example, I know a lot of Bluetooth headsets connect to the micro B as well. There's also a micro AB and a mini A, but I've rarely seen those in any implementation. Normally, it's this whole, L section right here that you'll see in practical use. In this nugget, we discussed resources and ports. We started off by talking about resources. These are various kinds of things that you need for your devices to be able to work properly, such as interrupt requests and DMA addresses. We also took a look at serial ports. Remember, that's kind of an antiquated way to connect, but it is also very reliable, even though it's slow. We took a look at parallel ports as well, which is also pretty reliable and a little bit faster, actually quite a lot faster, than serial ports. But these two are still kind of fading away in favor of other technologies. We also have infrared. This is a wireless way to communicate, but we'll talk about some better wireless ways to communicate in the future here, specifically with something like Bluetooth. We took a look also at IEEE 1394. That's FireWire or iLink, and a high-speed way to connect peripherals and devices, as well as USB, which is also a high-speed way to make these connections. Well, I hope this has been informative for you, and I'd like to thank you for viewing.